All right, let's talk about how to draw particle diagrams of something that undergoes a change. You're going to have more practice of this in the next module. But for now, I'm getting you to start thinking about this now. And part of science is being able to think critically about something. So I know in this lab on the analysis, I'm going to be asking you to draw before and after particle diagrams of a chemical change, which can be fairly complicated at times. But what I'm asking you to do is provide reasonable suggestions as to what might be happening. I'm not necessarily looking for one absolute answer. Instead, I'm looking for a reasonable answer to the solution. I'm going to give you a couple examples of before and after particle diagrams in this video. But before we do, let's review something. Mass is the number of particles. Volume is the amount of space that those particles take up. So amount of space particles take up. And we've reviewed that density is the spacing between particles, which is important, okay? Now, let's talk about something as simple as a change like this. I'm going to say before, B for, and then A for after. And the way that I like to think of it is because we're focusing on mass, that's the number one most important thing that we're focusing on here. I'm going to draw a box, okay? This box, I'll write it down here. Box represents what's on the balance. What is on the balance? So in other words, what that means is I'm recording the mass of the object, okay? Then after, this is like, would be whatever made it back onto the balance, okay? So let's say in this case right here, we are ripping paper. So before, we have one sheet of paper. Then after, we have tiny pieces of paper. Something like that. So we've ripped it up. But before we do it, we stick the whole piece of paper on the balance. And so on the balance, I'm going to draw a picture of just a piece of paper like that, okay? And then what I need to do is show the particles that make up that paper, okay? And so what I'll do is I'll just draw, it doesn't matter really what the particles look like, but I'm going to say, and it doesn't really matter how many particles I put in there either. But in this case here, I'm just going to say this piece of paper contains 6 particles. Now, let's say imagine that this balance read, 2 grams, 2.0 grams. What's going to be after I rip it up, and then I put all those pieces, let's say I rip it up something like this. There we go. So I've ripped up the piece of paper like that. What is the balance going to read? Well, the law of conservation of mass states that particles cannot be created or destroyed. Well, particles are indicated on these particle diagrams as mass, okay? So what I'm showing here is that the volume of the individual piece of paper are getting a little bit smaller, but the mass through a change never is created or destroyed. It's always the same. So what that means is these 6 particles here need to have 6 particles after. So maybe I show 2 up there, maybe 3 down there, 1, 2, 3, 4, 5, and then maybe 1 there. There you go. And so that shows the law of conservation of mass in a physical change. So that one's pretty simple, okay? Now, let's say we have something a little bit more complex. Like, for instance, something that you're very familiar with is camping. And in particular, let's say on the balance, we stuck some logs like that, okay? And let's say then after is the charred wood like so, like that, okay? Now, in this case here, the mass does some very interesting things. And so before we even start, what we need to do is we need to definitely make sure we show particles in the wood. And so I'm going to identify these as wood particles because it's important to identify what the particles are, okay? And in your case, when you're doing the sodium acetate and the vinegar and the baking soda and the carbon dioxide, that's important that you create some kind of key so that I know what particles they are. And you can do that through different colors or different shapes, and I'll show you both here, okay? In order for the wood to actually burn, you need another particle here, and that particle is oxygen, so it should be in the balance. This is just a key, though, okay? But oxygen is floating around here like so, and so notice how I did a different color. I could have done dots, but I'm just doing a square to represent that it's a different object in case you don't have different colors, okay? Now, this charred wood here has a different type of product, okay? And so I shouldn't have shown those guys hollowed in like that. So instead what I'll do is I'll show this right here still, but instead what I'm going to do is I'm going to show like a dot and a dot and a dot and maybe a dot like so. But all of the particles that I have on the left need to be shown on the right. However, this is a new substance, and so because it's making a new substance, somehow I have to combine it with the oxygen. And so what I'm going to do is I'm going to show this. Like that, okay? So what I've done, what this is showing is that charring happens because there is some oxygen being added to the wood itself, okay? And they combine, and that causes it to become something different. So it's a combining of these things. So notice I've got 4 green squares on the right, and I've got 6 over here, which means that somehow I've got to have these guys up here. Maybe I put them a little closer together, and I'll show you why. So I've got 6 now green, okay? And now notice over here I've got 5 yellow dots, which represent the wood particles, okay? Well, I know that you can see when you burn wood that the wood gets smaller, and you can see like smoke coming off too. So to indicate that the smoke or the gas is being given off as a different type of particle, but made up of the same materials, whoopsie, didn't mean to do that. What I'm going to do is I'm going to make a different particle. So right now this is the same as what I've drawn down below. But if I take 2 of those squares and put them on there, that's a different particle. And so this represents the law of conservation of mass because I've got 5 wood particles on the right and to the left, 6 squares, green squares on the right and the left, and I'm showing that some kind of change is happening. Now, please remember this represents before and after. So what I'm showing is that the particles are intermixing together to become new substances. Now, on your particle diagram, it's going to be kind of tough, okay? But again, I want you to just think about reasonably what might be happening. Oh, you know what? I forgot something very important here. This guy right here is, if I were to stick this guy on the balance, the mass would probably go down. That's because this is a gas, and this gas has is it's when it's burning, it leaves, whoop, it goes away, and it's not going to be recorded on the balance unless I have something to trap it with, like maybe a balloon. But in this case, I don't. And so therefore, to show the law of conservation of mass on my particle diagram, but show a deduction in mass, this particle I show outside the box. In other words, the box represents, again, what's on the balance. And so this shows particles are leaving the balance, but it's not violating the law of conservation of mass because particles cannot be created or destroyed. All it's doing is just leaving the system.